Hello everyone. I'm coming back with section 11.4, the quadratic formula. Let me have here. Okay. So in this section, we are gonna show you how to use the quadratic formula, which is x equal to minus negative b plus and minus square root of b squared minus 4ac over 2a. So basically, we use this formula to solve any quadratic equation written as ax squared plus bx plus c equals 0. For this method, I'm gonna say this is the most powerful method because you can solve any quadratic equation with this method. However, for this method, you have to be very carefully and with plugging for each constant for x a b and c over here. So other than that, when you plug in, when you do algebra, if you make a small mistake, then everything's going to be wrong. So carefully with that. Okay, now let's do an example over here. You can see I have 2x squared minus 3x plus 1 equals 0, which is a quadratic equation. And then I can apply quadratic formulas for this. For this one, a equal to 2, right? A equal to 2, b equal to negative 3, right? And c equal to 1. So then when I apply the formula, I'm going to have negative of b, which is negative 3 over here, right? And then plus minus b squared, which is negative 3 squared minus 4 times a, which is 2 times 1, which is c, and then divided by 2 times a, which is 2. And then trying to simplify the group under the radical, you have 1. And then plus negative 3 going to be positive 3. And then you have 3 plus and minus square root 1 over 4, which is equal to 1. And another case, 1/2. So, so that is a way to solve for using this formula. Also, you will learn about the discriminant. The discriminant, which is the one, the radicand, the one inside of the radical under the square root, which is b square b square minus 4ac. This one, right? And we call that discriminant. And we have three cases. The first case that if the discriminant is greater than zero, then we will have what? Two real solutions. And if the discriminant has equal to 0, then you have two real solutions. I'm sorry, one real solution. Okay, so if it equals 0, you're going to have one real solution. And the last case, if it's less than 0, then it's going to have no real solution. Right? See that? No real solution. And then you're going to have what? Two complex solutions. Two complex solutions. Okay. Okay, so for the equation, for example, the equation x squared plus 5 minus 1 equals 0. I have a in here is equal to 1, b 4, and c equals to 1. You see on the question. And then the discriminant will be b squared minus 4ac, which is equal to 4 squared minus 4 times 1 times negative 1, which is greater than 0. And then that means what? That means it's going to have two real solutions. Okay. Also, we're going to learn about quadratic formula and complex solution. if the remember that in the third case of the discriminant, that b squared minus 4ac less than 0 over here, we will have two solutions that are complex numbers, and which means it's not real number, right? If k greater than 0, the solution to x squared plus k equal to 0 are given by x equal to plus and minus I square root of k. And say let's solve for 2x squared minus x plus 3 equal to 0, and we have, like, when we apply the quadratic formula, and we're gonna get 1 plus and minus square root of negative 23rd over 4 equal to 1/4 plus and minus I and square root 23rd over 4. So another example is like x squared plus 7 equals 0 can have solution as x equal to plus and minus I times square root 7. Okay, so now let's do some more example down here. Say example 7, solving a quadratic equation. Solve the equation 2x squared minus 3x minus 1. So let's list out a equal to 2, b equal to negative 3, c equal to negative 1. Okay. I will have apply the quadratic formula, right? I have x equal to negative b plus and minus square root b squared minus 4ac over 2a. Right? Why I write like this? Because I want to keep rewrite the formula so I can remember the formula. Okay, so now time to apply. So I have negative of b. What is b? Negative 3. So put negative 3 and plus minus square root of negative 3 square minus 4 times a, which is 2, and c is negative 1. Okay, and then divide by 2 times 2. Okay, so then I have negative gonna be positive 3, and then plus minus 4. You can use a calculator to find the number inside over here, but if you want to do by hand, you have negative 3 squared, which is 9, and then minus with 4 times 2, which is 8, and times with negative 1, we're gonna be positive 8. Right? So that, and then divide by 4. Which can be rewrite as 3 plus and minus square root of 17 divided by 4. Right? So in this case, you can have two cases. X equal to 3 plus 17, square root of 17 over 4, we equal to 1.78. Or x can be rewrite as 3 minus square root of 17 over 4, which can be rewrite as negative 0.28. Okay, so those are the solution of this quadratic equation. Okay, so let's move to problem B. We're going to solve the equation 25 x squared plus 20x plus 4. So here list out A, 25, B, 20, C equal to 4. But remember that sometimes they don't gonna write the quadratic equation in this form. They mixed up, right? So but you in that case you must to organize to make it become look like this formula, right? You need to make sure the x squared term has to be at first, and then you get the a, right? And then the middle term going to be x. See that? So that's the way. Okay, so now let's apply x of the quadratic formula. So x equal to negative b plus and minus square root of b square minus 4 times ac. See that? I keep rewrite it so then I can remember it easily, right? And then substitute. Negative b is 20. So I just gonna write with parentheses so I don't gonna mess up with that. Plus and minus 20 square and minus 4 times a times c is 25 and 4. Right, see that? And then everything, let me see, everything divided by 2a, which is 25. Okay, so now I will have negative 20 plus and minus with a square root of 20 square minus 4 times 25 times 4, which is going to be equal to 0. See, you can use a calculator and see that, right? And then to have 2 times 25 will be 50. Okay, so if you remember the discriminant when it equal to 0, then you're gonna have, one solution, right? One solution for later, right? Because discriminant equal to 0, then we're gonna have one solution. So for the first column, I have 17 here. Discriminant is greater than 0, right? So then I can say this is gonna have two solutions. As you see at the bottom, there are two solutions. Okay. So now let's come back with this bottom. Then I will have x equal to negative 20 divided by 50, which equal to negative 2 over 5. That's the answer. So, okay. Remember that's the square root 0 going to be equal to 0. Okay. Remember that square root 0 equal to 0. Okay. Now, let's move down and do problem C. Oh, I cannot do that. Okay. So this problem C, I have a equal to 5, b equal to negative 1, right? And c equal to 0. And you want to solve this equation, right? Use a quadratic formula, right? X equal to negative b plus and minus square root of b square minus 4ac divided by 2a. Substitute. I have negative of negative 1 plus and minus the square root of negative 1 square minus 4 times ac, so 4 times 5 times 0. Then I have 2 times 5. So now, what do I have? Oh, why I have C0 here? I make a mistake. C equal to 3, right? Make a mistake. So I have 1 plus and minus the square root of negative 59 divided by 10. And you see over here the discriminant, right? Discriminant is less than 0. What happened? I'm gonna have no real solution. Okay, we're gonna be the 2 complex solution later. But for now, we're gonna just say oh, no real solution. No real solution. Okay, so this for now you can just stop here and state that there's no real solution with the k that is less than 0. So because discriminant. Oh my God. Less than 0. So that. Okay, so we have finished C. And I have I have like a table that making the condition for 3-way to solve AX to solve quadratic equation. Okay. So in here I have x squared minus x and minus 2 equals 0, which is a quadratic equation. And first thing you the first equation, the first way is we call like symbolic solution. We using in here is x is a quadratic formula, which is x equal to negative b plus minus b square minus 4ac over 2a, and I'm gonna have x equal to 2 and arm negative 1. And another way is using the numerical solution. Which you can have like you can have like a series like you have like a table t tables, and then find out there is a value changing from from a positive over here to a negative over here. See that changing, and then from negative here change to the positive. Then in the middle is should having two solution whenever it's changing in between. So this way usually is it's hard for you at this level, but when you go to the maybe calculus or maybe higher than that, you're going to learn more about this numerical solution. Another way to see the solution, which is called graphical solution, and this way you can also for your level right now, you can use to this way to see the solution easily, by maybe by Desmos or by your TI-83 or TI-84 with, or like graphing calculator. You can see whenever the graph is cross the x-intercept, we're gonna be the solution of the graph. So in here, the graph is cross the x-intercept as -1, 0, and 2, 0. So -1 and 2 in here gonna be the solution of the function. Okay. The equation actually. Let's move to let's move to, let's see, example number 2. We're using discriminant. Okay, and for this column, we're gonna use the discriminant to determine the number of solution to a quadratic equation. Okay, so so like I say above here, there is 3 cases. One is greater than 0, then you have 2 real solutions, and the second one equal to 0, then it's become 1 real solution, and the last one is less than 0, it's going to give you no real solution. Okay, so let's see how can I apply it for this problem. Okay, so let me see. So I'm gonna have to, so in this case, you can see that this equation haven't been to be a quadratic general form. Yeah, right. So how can I change it? So I want to make this 20x move to the left hand side and the right hand side becomes 0, right? You see that? So step 1, convert equation to be in the form as ax squared plus bx plus c equal to 0, right? So for this step, I'm having 4x squared plus 25 equal to 20x, right? So I need to subtract both hand side by 20x, and I have subtract both hand side by 20x. So I have 4x squared minus 20x plus 25 equal to 0. Okay, so now, if you like, you actually can, divide both hand side by 4 to reduce the constant, right? So divide both side by 4, or divide. So divide 4. Everyone divide by 4. So I have x squared minus 5x plus 5. No. Oh, it doesn't work because 25 cannot divide by 4. So I'm just gonna keep it as this form. Okay, that's fine. No worry. So now I list out A equal to 4, B equal to -20, C equal to 25. Okay. The discriminant is b squared minus 4ac, right? You have remember that. And b squared is -20 square and minus 4 times A, which is 4. And then C is 25. So what do I have now? It's going to be equal to 0. So that's give me, uh, one real solution. Let's tell me that there is one real solution for this equation. And if you want, you can solve it, but I don't think that's we have to do. We have to do because it's solve the equation, right? Okay, so let's go ahead and solve it. Okay, so let's go down. So let's solve it. So I have x will be equal to minus b squared plus and minus square root of 4. No, sorry. Minus b plus minus b squared minus 4ac, right? Divided by 2a. Where, now I can substitute. I have negative b, which is negative 20 plus and minus discriminant equal to 0, so just square root of 0, and then have 2 times a, which is 4, and then have 20 divided by 8, and that gives me 2.5 as the answer. Okay, so now now I have using the no, I'm done. I don't have to grab it, but yeah, I thought we have to grab it. So let's move to example number 3. This column asking you to analyzing the graph of y equal to ax squared plus bx plus c. Okay, so let's fx equal to negative 1/2 x squared plus c plus 3 over 2. And then here's a graph y equal to fx open upward or downward. Is this graph wider or narrower than the graph of y equal to x squared? So in this case, we actually just in this question, we actually just gonna consider about a, right? In here, I would like to list out a in here equal to negative 1/2, b in here equal to 1, and c in here equal to 3/2. Right? Then seeing a equal to negative 1/2 is less than 0. So then fx open downward. Okay, downward. And seeing absolute value of a equal to 1/2, right? Which means absolute value of a is greater than 0 and less than 1. That's gonna give me the graph is wider than the graph of y equal to x squared. Right? So wider. Okay. Let's move to the next question. Find the axis of the symmetry and the vertex. So to find the vertex, Find the symmetry and vertex. I just want to find the vertex, right? Or I can, find the axis symmetry first. Axis symmetry. Axis of symmetry, which is in the format x equal to x vertex equal to negative b over 2a. And I can just substitute negative b in here is 1, so negative 1 over 2 times negative 1 half, right? So 2 times negative 1 half can be cancelled with 2. And then now I have only negative 1 on the top and negative 1 at the bottom, equal to 1. So symmetry is, actually the symmetry is x equal to 1. And now I need to find the y vertex, y value of the vertex, which equal to f of 1. And then I have negative 1 half, 1 square plus 1 plus 3 half. That's going to give me negative 1 half plus 1 plus 3 half, which equal to 2. And the y value of the vertex. So then vertex is 1, 2. Okay. Now, if I asking you about find the discriminant and determine the number of x in the set, so the discriminant let's label it is d, right? Equal to a b squared minus 4ac. And that b squared in here is 1 square minus 4 times a is negative 1 half. What is c? I forgot. 3 half. Okay. So 3 half. So I have this 4 can be cancelled because of this 2 number 2. Okay, and then now it's become 1 negative times negative 1 become 1. So plus with 1 times 3 is 3. And that give me 4. And this number 4 is greater than 0. So then we have since the discriminant is greater than 0, then usually if you have an equation of the quadratic form, then you have two solutions. But in here is we are having a function, then we're gonna say like we're gonna have 2 action steps. So there are 2 x intercept. And then I have just circle the answer. All right, so let's move to next one. Find the y-intercept and the x-intercept. Okay, so in order to find the y-intercept, you're gonna left. So find y-intercept. Right. Let x equal 0. So then we have f of 0 will be um, will be -1/2 times 0 square plus 0 plus 3/2, which equal to 3/2. So then, so the y-intercept will be x is 0, y is 3/2. Right? So one question. In order to find x-intercept, we have solve f of x equal to 0. So we have -1/2 x squared plus x plus 3/2 equal to 0. So we can use quadratic formula, or I think for this case I can just multiply by -2 both hand side. Okay, so I multiply by -2 both hand side, and we'll get x squared minus x minus 3 equals 0. So multiply by -2 both hand side. Okay. So now, if you apply the AC method, you have A times C is -3, B equal to -1. So two number, the addition is -1 and multiplication is -3. I could think about, oh wait, did I miss anything? Oh, I missed number 2 over here, right? Okay, so this will be -2. Okay. I could think about -2, -3 and 1. Okay, so then I can factor it as x minus 3 times x plus 1 equal to 0. So then, you can use zero product property. Okay, so zero product property, you have x plus 1 equal to 0, or x minus 3 equal to 0. And then you say x equal to -1 or x equal to 3 as the solution for fx equal to 0. So then we're gonna say x-intercept will be actually you have to find the y value for each case in here. Okay, so for x equal to -1, we have f of -1 will be say -1/2 times 1 square plus -1 square plus -1 plus 3/2, right? And then I have 0. Oh, actually I don't have to do this. I'm just gonna say because the y-intercept, right? So then it's just gonna be the y value should be 0. So I'm gonna just say y-intercept are -1, 0, and 3, 0, right? Because they are y-intercept, so then the y value has to be equal to 0 for each case. Okay, done. Now, the last column, no, not column, last part is E, which is sketch the graph of y equals to Lx. So let's sketch it. So the graph had to be downward, and y-intercept is sorry, the y-intercept is what? So this week x-intercept, right? X-intercept, right? So for the x-intercept, I have -1 and 3, right? So put -1 here. 1, 2, 3. Yeah. And the y-intercept was 3/2, right? 3/2. So here is 1, here is 2, 3/2 is here. So, and then I have symmetry, a vertex. What is the vertex of y? Vertex was 1/2. Okay. Vertex was 1/2. 1, 2, sorry. 1, 2 over here. So it should look like go to the 3 point, go there. Okay. You can use more point to correlate it, but I mean, I just gonna stop with this point, and that's enough for me to draw it. For the symmetric axis of symmetric is here. Okay. So what else? Solving a quadratic equation that has complex solution. Okay, so I want to solve x squared plus 5. So that for this problem, I can just, subtract 5 both inside. I have x squared equal to -5, right? You see that? Then now, I can, square root both inside. Okay, so I have square root of x squared equal to square root of -5, right? In this case, you can say no real solution, but that now I consider about complex solution. So I can rewrite it as x. Now apply the square root property. I have x equal to, remember that I have two ways. It's positive and negative of a square root of -5. Right? Square root of -5 can be rewritten as plus or minus a square root of 5 times square root of 1. Remember that negative square root of -1 can be rewritten as I. Okay, can be rewritten I. Remember that I equal to negative square root of -1. So we still have to have two answers, but in this case it's become a complex solution. Okay, so now what about with this problem 2x squared plus x plus 3 equals 0? How can I solve this one? Okay, so let's have a, b, and c. 2, b equal to 1, c equal to 3, right? Then I have x will be equal to -b plus minus square root of b squared minus 2ac, 4ac, sorry, divided by 2a. That's give me -1 plus and minus square root of 1 square minus 4 times 2 times 3 divided by 2 times 2. And now I have negative 1 plus with and minus squares a square root of, you can use a calculator now, but you're going to have negative 23rd divided by 4. So I can split it to become 2 k's. X equal to negative 1 plus square root of negative 23rd divided by 4. Or x equal to minus 1 minus a square root of negative 23rd divided by 4. And, apply the fraction property. I can have x equal to negative 1 over 4 plus with a square root of 23rd times I divided by 4, right? Or x equal to negative 1 4 minus for square root 23rd I divided by 4. Remember that negative square root of negative 23rd can be rewritten as square root of 23rd. Okay. So this should be the answer for this guy in the form as in the general form of the complex number. Okay. Part B, I want to solve 3, 4x squared plus 1 equals to x. So I want to write it in the form as 3, 4 x squared minus x plus 1 equals 0. Okay, minus both sides by x. Because I want to make it become like quadratic equation. Okay, so now I have A equal to 3, 4, B equal to negative 1, C equal to 1. So I have a x equal to negative b plus and minus square root of b squared minus 4ac divided by 2 times a, which equal to negative of negative 1 plus and minus square root of negative 1 square minus 4 times 3, 4 times 1, everything divided by 2 times 3, 4. Right. And now I have a 1 plus and minus for a square root of, use a calculator, you're going to get negative 32. And then divided by 6. Oh, wait a second. Let me see. No. Okay, so I have actually in here is negative 2 divided by 2 and 3, 6 divided by 4. So we're going to have 3 over 2. So, okay, so I have to move out this one. I can rewrite this as, if I multiply by you know, if I can if I can write this as um, 1 plus minus square root of negative 2 divided by 3 half, which is going to be equal to multiply by 2 times 3, 2 over 3. And then which mean I can rewrite it as x equal to 2/3 plus and minus a 2 square root of negative 2 over 3. And that can be rewrite as 2/3 plus and minus 2 2/3 times square 2 square root 2 times I. Right, like that. So that should be the solution for this. Okay. So let's move down to the last problem. Example 6. Completing the square to find the complex solution. Okay, so solve x times x plus 2 equal to -2 by completing the square. Okay, so let's do this one by completing the square and see what happens. Firstly, I need to, maybe I have to do distribution. So I have x squared plus 2x. Oh, what happened? Equal to -2. Right? I do distribution for the left hand side. And then I'm going to add 2 both hand side. Equal to 0. So we have b in here equal to 2. Actually, no, I can just gonna use this and then say, oh, b in here equal to 2. So then b over 2 will be equal to 1. And then also I have b over 2 square will be equal to 1. Right? So I'm gonna add, for the second step, add both sides by b over 2 square. Equal to 1, right? So let's add both sides. I have x squared plus 2x. Okay. Plus 1 equal to -2 plus 1, right? I add both sides by 1. And then I have the left hand side now changed to be a perfect square trinomial, which is x plus b over 2, which is 1. Everything square. The right hand side become -1. Right. And then I'm gonna apply the square root property. Have x plus 1 equal to plus and minus a square root of -1. So in here I say that for this step I'm going to say perfect square trinomial. And this one is square root property. And last one, I'm gonna have x equal to -1 minus 1 both sides, plus minus the square root of -1 and I can rewrite it as -1 plus and minus I as the answer. So this will be the answer for this problem by using complex solution. Okay, so I have done section 11.4 quadratic formula, and we'll see you in the next session.